welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in today's video we'll be having a look at differentiation using the product rule. So before I begin, I will strongly advise you to go over my previous video on the basics of differentiation, as that would lay a solid foundation for you to build on in this video. So without any more delays, let us begin. Right, so what is the product rule? Let me start on a complex note, and then I'll break it down into simple explanations. The product rule, when differentiating, you can say is dx is equal to, and the formula for the product rule is v du dx plus u dv dx. Now when you look at this at first, it may seem a bit complicated, but let me just break it down for you. Now we know when we say something like dy dx, the reason this is y over here is because we are differentiating some sort of a function which is represented as y equals to, for example, let's say 3x plus 4. The reason we put y over here is because the function is represented or is in terms of y. Now over here I've put uv. That means our function that we are differentiating is in terms of uv. Now what is our u and what is our v? These are nothing but two separate functions that are being multiplied together. So essentially we're finding the derivative of two separate functions being multiplied by each other. So for example, let's say we are asked to find the derivative of something like 3x brackets 2x squared. So in this case, if I was to find the derivative, I would use this product rule over here. I would label any one of them u. So let's say 3x is our u and 2x squared is our v. And I would now follow the formula. Now what essentially the formula says is you multiply one of the functions with the derivative of the other one, and then you multiply the original other function with the derivative of the other one, as the formula suggests. As you can see over here, the first part is v times du dx, so our v, which is 2x squared into du dx, which is differentiating our u, and differentiating 3x, you get 3, so 3. And then you add the other part, which we have over here as u dv dx. That means our u, which is 3x, so plus 3x, into our dv dx, that is the derivative of 2x squared, which is 4x. Now you can just simply open your brackets and simplify this. On the left over here we have 6x squared. On the right we have 12x squared, and all of this gives you 18x squared. Now the question that may be arising in your mind is that, well, why are we doing this complicatedly? Why not just expand these two as it is, just do 3x times 2x squared, which is 6x cubed, and then just find the derivative dy dx of this as normal, which would essentially also give us 18x squared, which, as you can see, is a lot quicker and a lot efficient. But this only works for questions that are limited to these type of functions. If you have functions that are a bit more larger, for example, something like this, 3x plus 7 into maybe like x squared minus 22x plus 7, just an example, it would take you a whole lot of time to expand the brackets, collecting your like terms, and then differentiating everything. And that would take a lot more than if you just use the product rule. So the product rule is maybe not the best in terms of short-term questions like the one we did earlier, but in terms of long-term questions that are longer, that take longer time, product rule is a really handy tool to have. Now that is essentially how the product rule works. It really is, it is an alternative of instead of multiplying and opening up the brackets and finding the derivatives individually, you can find them as a whole using this process. Now this is for when you have two functions, that is function u and function v. Now what if you have two or more functions, really? What if you have 3 functions or 4 functions or 5 functions? Now the ground foundation is the same, to be honest. For example, let's say I have 3 functions. I have function f, I have function g, and I have function h. They're all being multiplied by each other, and we want to find the derivative of the equation of the function fgh. So my formula would now be d into fgh, because that is essentially our y in this case, all over dx equals to f prime gh plus fg prime h plus fg h prime. Prime is simply another way of expressing differentiation, or the dy dx of that particular function, the derivative of that function. That's what prime suggests, that little comma at the top, or apostrophe rather. So in layman terms, basically all this formula is suggesting is that you take the derivative of one of the functions and multiply it with the other 2 functions as a whole. Then you take the derivative of the next function and multiply that with the other 2 functions as a whole, and likewise for the third one as well. Now, a lot of exams do not require you to actually do this, because this can take a very long time opening up and finding the final answer. They usually want you to give your final answer as an expression, as an unsimplified expression, just to show that you know what exactly is the process being used. Now, similarly, if it was more than 3 functions, let's say 4 functions, let's say I had functions a, b, c, d, a, b, c, d, all being multiplied by each other. So again, to find the derivative of all of this as a whole, a, b, c, d, all over dx is the same thing. It's just as it's a chain reaction, it continues going. You would take the a prime multiplied with b, c, d, plus a with b prime, c, d, plus a, b, c prime, d, plus a, b, c, d prime. So you take the derivative of each of them individually and multiply them with the other 3 functions as it is. So you can see from this is really the most important one, the one that has 2 functions. This is the one that's most commonly asked. Around 90% of questions involving product rule, 90 to 95% involve these type of questions. So you can see it really is it's a chain process from this. If it's 2 functions to 3 functions to 4 functions, if it's 29 functions, then you would take one of the functions derivative of them and then multiply with the original other 28 functions. So that's how it goes. And more or less, product rule is not exactly a topic on its own. It's more of like a hidden topic. You have to read between the lines. It's part of a lot of other processes, a lot of other methods which involve the product rule. So that's why it's a very useful weapon that any mathematics student should possess in their arsenal. So let's look at the first example. First example, we have 2x plus 4 into x squared minus 3x plus 9. And we are to find the derivative of this. Now, I could show you both the methods using the product rule and also expanding all of this, but expanding all this will take time. Of course, I will recommend you use both methods. Just try it out yourself with a pen and paper and see for yourself which one is quicker. I'm definitely sure the product rule will be quicker. So let's go ahead and use our product rule. Let's just label this one u, label this one v. Either way, if we label the uv and the vu, we'll still get the same answer. So our formula, as we know, is duv dx. Formula is v du dx plus u dv dx. So our v, that is our quadratic equation, that's x squared minus 3x plus 9, so x squared minus 3x plus 9 into the derivative of 2x plus 4, which is 2, plus u dv dx. Our u is the 2x plus 4 plus the derivative of v of the quadratic equation, and differentiating x squared minus 3x plus 9, you arrive at 2x minus 3. So all you do is just expand the brackets and simplify. Expanding this side, we have 2x squared minus 6x plus 18. If you're not comfortable with expansion of bracket, you can also look at one of my previous videos on expanding single, double and triple brackets. And over here, if you expand this, we have 4x squared plus 2x, because 2x times minus 3 is minus 6x, and then 4 times 2x is 8x, minus 6x plus 8x is 2x, and minus 12. And collecting your like terms, 2x squared plus 4x squared, that's 6x squared, minus 6x plus 2x is minus 4x, and 18 minus 12 is plus 6. And that is the final answer. That's the derivative of the equation, or of the functions uv being multiplied. So that was your final answer for that example. On to the next one. Okay, I have 5x minus 9x cubed into 8 plus x squared. Okay, again, let's just change it up this time. Let's say this is our v instead, and this is our u. So again, our formula duv dx is equal to v du dx plus u dv dx. Our v is the equation on the left of the multiplant, so that's 5x minus 9x cubed into our du dx, which in this case is 2x, because if you differentiate 8 you get 0, you differentiate x squared you get 2x, plus our u dv dx. Our u is 8 plus x squared, and our dv dx, that is differentiating this one over here, we have minus 27x squared plus 5. I just put the greater power in front, differentiated this part over here first and then this part over here. Same way, if you could do the other way around first, it's totally fine. So now we can go ahead and expand and simplify this side over here. We get 10x squared. Be careful with the powers because there are a lot of x's involved over here, so that's 10x squared minus 18 minus 18x to the power of 4, plus we can just use square brackets first so that we don't have any difficulty with the signs. Expanding this side over here, we have 8 times minus 27 is minus 216, I believe. Let me just check real quick. Yeah, it is. Minus 216x squared plus 40 minus 27x to the power 4 plus 5x squared. And now we just simplify, collect our like terms simply. We're going to have minus 18x to the power 4 minus 27x to the power 4, that's minus 45x to the power 4. 10x squared minus 216x squared, that's minus 201x squared. Sorry, minus 206x squared, not bad. And then we have, oh, sorry, that's 10x squared minus 21x squared plus 5x squared, that is 201 squared. That was right, sorry, minus 201 x squared, and then the only term we have that's independent of x is 40, so that comes as it is, plus 40. And that is the answer for that question. Now, even if you feel like this is a longer method, I mean, if you were to actually expand all this first and then find the derivative of them individually, that would take some time as well. So either how, anyway, whichever one works the best, but I would advise the product rule. On to the next example. I have 7x plus 7 into 12x to the 4th power minus 2x cubed. So again, let's just say this is our v, let's say this is our u, formula d u v dx. Some exam boards do pay a lot of emphasis on you writing the formula down, some don't, but just to be on the safe side, always write down your formula. This is v du dx plus u dv dx. Just write it like this, so even if there isn't mark, you can get that mark. Even if there isn't a mark, it does help your workings to be a lot more organized and a lot more easier for the examiner to follow along. Rv, in this case 7x plus 7 into our du dx, that's the derivative of this here, which is 48x to the power 3 minus 6x squared, plus our u dv dx, our u, that is our 12x to the power 4 minus 2x cubed, into our dv dx, that's the derivative of 7x plus 7, which is 7. Expanding our brackets again, this side over here, this is 7 times 48, that's 336, x to the power 4 minus 42x to the power 3 plus 336x cubed, yeah, and minus 42x squared, and taking care of the other side, plus, let's use our brackets just to make sure we don't get confused with the signs. 7 times 12x to the power 4, that's 84x to the power 4, and then minus 14x to the power 3. So collecting our like terms, we have 336x to the power 4 plus 84x to the power 4, that's 420x power 4. We have minus 42x cubed plus 336x cubed, that's 294, and then we have minus 14x cubed as well, so that's plus 280x cubed, and we only have one term to the power of x squared, and that is minus 42x, so minus 42x squared, and that is the final answer for that example. So that was for that, and one final example for today that I'll be going through is the one that has 3 functions involved. We have to find the derivative of x squared plus 6 into 7 minus 8x into 3x minus 5x cubed. Right, so it asks us to find the derivative of this function and leave it in an unsimplified form. So let's say this is our f, this is our g, this is our h. So we are to find the derivative, so we have d of f g h over dx equal to our formula, as we said, was f prime gh plus f into g prime h. Again, prime is just the derivative of that particular expression, plus f g h prime. So going ahead and putting this in as an unsimplified form, really, f prime, that's the derivative of x squared plus 6, and that's 2x. So we have 2x into g, that's 7 minus 8x, into h, which is 3x minus 5x cubed, plus f g prime h. Our f is still x squared plus 6. Our g prime, that's derivative of g, is minus 8. And our h is still 3x minus 5x cubed. And then plus f g h prime. So our f is still x squared plus 6. Our g is still 7 minus 8x. And then our h prime is the derivative of 3x minus 5x cubed, which is 3 minus 15x squared. And this is how you are asked to most times leave your final answer, as in an unsimplified form, because if you were to expand on this, it would take an age to get to your final answer. However, you can go ahead and try this by yourself, expanding all this. The final answer that you should get is 240x power 5 minus 175x to power 4 plus 864x cubed minus 567x squared minus 288x plus 126. That should be your final answer you should get once you expand all of that. So that brings us to the end of this video. Hopefully you understand this topic and you enjoyed the video. Thank you for watching. Please do not forget to perform an LSS, that is like, share and subscribe, and have a nice one, guys.